All right. Okay. So, again, we're looking at a fraction. What you want to ask yourself is there a Pythagorean identity that involves both? So is there a Pythagorean identity that involves both? The answer to this one is yes. When the answer to that is yes, you are going to factor. When the answer to that is yes, you're going to factor. So what I start with is this. 1 minus sine squared x over 1 plus sine x equals sine x. All right. Okay. 1 minus 1 plus sine x, 1 minus sine x over 1 plus sine x equals sine x. All right. Anybody have any issues with what I've done so far and what I've done? All good? So because there is a direct Pythagorean relationship between the numerator and denominator, I factor. That's going to allow me to cancel out what? That's in both the numerator and the denominator. 1 plus sine x is going to cancel out. That leaves me with 1 minus sine x equals sine x. And now you're just adding and subtracting. What's the 1 minus 1 going to do to each other? Cancel out. And you got a negative of negative sine x. Negative of a negative turns it into a positive. So I got sine x equals sine x. And I'm done. How's that? What do you mean? No. You don't have to like show distribution or whatever. Like combining like terms, things you've learned in previous classes, like canceling and factoring, no. You just have to write them. Now, yes sir. I got a negative outside and a negative inside. So the negative turns into a positive. Now, what you can do in the very beginning if you'd like, and again, this is just to show you what you can do. Some people are going to subtract 1 from both sides right away. What's the 1 minus 1 then going to do on the left-hand side? Cancel out. And you're going to have negative cosine squared x over 1 plus sine x equals sine x minus 1. You'll still eventually get to the place where they're both what? Exactly the same. The difference is instead of both being equal to sine x, more than likely they're both going to be what? Sine x minus 1. So you'll still get there. You'll just have different steps moving along the way. How's everybody doing thus far? Making sense? Alright, now underneath. Sine x plus tangent x over sine x equals 1 plus secant x. The difference with this one is my denominator has one term. We're going to call that a monomial. When you have a monomial denominator, I would divide it through. So in other words, I would take the sine x and put it over your denominator, which is sine x, plus tangent x over sine x. The difference is it's a monomial, so that means I do that. Now, what's the sine x over the sine x going to do to each other? Cancel out, leaving you with 1. And then all I'm going to do is rewrite my fraction as a division problem. Now, you do not need to write down the right-hand side if you don't want to. But the reason I'm doing it is this, for this problem. Do I have a 1 there? Yes. Do I have a 1 there? Yes, they match up. So I know I'm done with that part. Does that make sense? So I'm going to focus on this part now. Tangent x divided by sine x. Tangent x I'm going to rewrite as sine x over cosine x. When I divide fractions, I end up what? Multiplying by the reciprocal. Okay? In this case, I'm going to leave it as 1 over. I'm not going to rewrite it as cosecant. Because this is the idea in your notes that when in doubt, write everything in terms of sine and cosine. What are the sine x's going to do to each other? Cancel out. And now you have 1 plus 1 over cosine x. Now you have a choice. Most people are going to rewrite 1 over cosine x as what? What's the inverse or reciprocal of cosine? Secant. 1 plus secant x equals 1 plus secant x. And you're done. Your other choice, if you wanted to, is you could rewrite secant as what? 1 over cosine. And you'll still be right because both sides are what? Exactly the same. As long as they're the same, you're good. It could take one step, it could take multiple steps. Alright? Everybody good with a monomial in the denominator? Okay, let's go on the back then. I have 1 over tangent x plus tangent x equals secant x cosecant x. Again, there's different ways of writing this. You could take the 1 over tangent x and rewrite it as what? Cotangent x. Alright? Instead, I'm going to write it with a common denominator because we're working with fractions today. So this becomes 1 over tangent x plus tangent squared x over tangent x. So just like you did in Algebra 1, just like you did in Algebra 2, you're finding a common denominator. Does everybody understand where those two terms come from? Left hand stays exactly the same. Okay, so here's the idea. Cassie, you ready? See how this has a denominator of tangent x? That means this also needs to have a denominator of what? Tangent x. So I'm going to take tangent x and multiply by 1 because I don't want to change the number. So you write that with the numerator and the denominator being exactly the same. So that's all you're doing. Last year you did it with like x plus 2 and x minus 3 in the denominator. Now you're just doing it with trig functions in the denominator. What? That's okay. Tangent x times tangent x. Okay. So that's tangent squared x. Same question? Good. So I'm multiplying it through. Okay? At that point, I can rewrite it as a single term. 1 plus tangent squared x over what? Tangent x. From Pythagorean identities, 1 plus tangent squared is secant squared. Alright, now, this is how looking at your problem can help you. See how secant x is in your denominator? See that? Or in your final answer, sorry. I personally would rewrite this as secant x times secant x over tangent x. Because I know these secant x's must what? Match up. And once they do, I don't have to worry about that part anymore. Then I would take this and rewrite it as a division problem. Secant x divided by tangent x equals secant x times cotangent x. And then I'd rewrite everything in terms of sine and cosine. So secant x is 1 over cosine x. Cotangent x is cosine x over sine x. What are the cosines going to do to each other? Cancel out. And you're going to have 1 over sine x, which is equivalent to cosecant x. Now, when I did all this, I didn't touch the secant x at all, so that's still there. And then that all converted to cosecant x. So boom, now the two sides are exactly the same. Yes, sir. I divided it. So basically, and I'll show you a different way to do it in a second. So basically, I rewrote this. So I broke the secant squared into two different secants. So I turned that in my head into secant x times secant x over tangent x. This first secant x became that secant x. This second secant x I put over tangent x. Now if you want, and you'll still get, you can do this, secant squared x divided by tangent x. If this is easier for you, feel free. See what I did? So I just took that before I broke it down and turned it into a division problem. Secant squared is 1 over cosine squared. Division turns into what? Multiplication. When I do that, I flip my trig. Tangent becomes cotangent. That'd be cosine over sine. Good? And then you can do it that way. You still get the same answer. All right, now the big finale, and then you're off to practice. Cosine squared x minus sine squared x equals 1 minus tangent squared x over 1 plus tangent squared x. I have a lot of squares up there. I want to find a Pythagorean identity because that's going to turn a binomial into a monomial. And that's right here, 1 plus tangent squared x. 1 plus tangent squared x by Pythagorean identity is secant squared x. So this becomes 1 minus tangent squared x over secant squared x. So all I did is converted the denominator. Good? Yes, sir. Okay. So I did. From the problem we did earlier, is my denominator now a monomial? Yeah, so I can break it down. The first part is 1. I write that over secant squared x. The second part is tangent squared x over secant squared x. What is 1 over secant squared x equivalent to by reciprocal or inverse identities? Cosine squared x. Good? That cosine squared x now matches up with that cosine squared x. So I don't need to work with that anymore. Make sense? I'm trying to work so that I can work with as little as possible. So that means I'm taking this. Now I'm going to go back to just treating it like a division problem. So that becomes tangent squared divided by secant squared. Tangent squared by your quotient identities is sine squared x over cosine squared x. What am I going to turn the division into? When I divide fractions, division turns into multiplication. And then I do the inverse. The inverse of secant squared is cosine squared. Before moving forward, does everybody understand how division by secant squared x becomes multiplication by cosine squared x? I flip my sign, I flip my trig. Well, what then are the cosine squared x's going to do to each other? Cancel out. And I'm going to be left with cosine squared x, which I got from the beginning, minus what's done after I canceled, which is sine squared x. And you'll notice the two expressions are now exactly the